So dear students, we now will talk about a result on page 23. Limit x approaches infinity. 1 plus 1 by n raised to power n. The answer of this limit is e. This e is a specific number 2.718. So students, we have to evaluate this limit. Solution begins. We first handle this structure and later we will apply limit on it. It is n approaches infinity. N approaches infinity, 1 plus 1 by n raised to power n. The answer is e. By binomial theorem. He begins it with by binomial theorem. We have, by binomial theorem, we have 1 plus 1 by n raised to power n is equal to, we know the binomial series, 1 plus x raised to power n is expanded as 1 plus nx plus n minus 1 by 2 factorial x square n minus 1 n minus 2 by 3 factorial x cube, so on. What is it? It is binomial series. We studied in unit 8 part 1. So that series expansion is used here. How is it? 1 plus nx, 1 plus x raised to power n, 1 plus x raised to power n is written as 1 plus nx. 1 plus n is the power, x is this value written with 1. 1 plus nx plus we write n minus 1 by 2 factorial x square. X is of the form 1 by n here. It is squared. Plus n minus 1, n minus 2 by 3 factorial power 1, power 2, power 3, 1 by n cube, so on. Students, you need to understand it. This is the general form of binomial series. We expand this form as it is matching with it. We expand this form according to this expansion. This expansion name is binomial series. 1 plus x raised to power n is expanded as 1 plus nx plus n minus 1 by 2 factorial. This is n power. n minus 1 by 2 factorial x square. This is x. Then n minus 1, n minus 2 by 3 factorial x cube, so on. Look at it, 1 plus x raised to power n. Only the value of x is changed. Rest of the values are same. X is 1 by n. So look, 1 plus nx. X is 1 by n. Plus n minus 1 by 2 factorial x square. X is 1 by n. Plus other values are matching in these two structures. This is general, this is specific, this one. Both are matching, only difference is the value of x. So everything in the expansion is also similar, only in place of x we have 1 by n. n minus 1, n minus 2 by 3 factorial x cube, so on. So students, this was the general form and we expanded according to this general form. Now we will simplify it. How can we simplify it? It can be written as 1 plus 1. Both are cancelled. And what can we write here? 2 factorial can be written 2 factorial. And this is n square. N square can be written as n minus 1 divided by n dot n, it can be written as. These two are cancelled definitely. Plus here 1 by 3 factorial. Then we write n minus 1, n minus 2. We can write this n cube as n. These two n are cancelled and so on. This continues like this. Then we write 1 plus 1 plus 1 by 2 factorial. It will be what? N by n is 1 minus the other value is 1 by n. Then we write 1 by 3 factorial. This is n by n is 1 minus 1 by n. It is n by n is 1 minus 2 by n. This can be done, students. This is a little new form. You need to understand. We divide this n separately in this factor. N by n we write, that becomes 1 and 1 by n. We write n by n, it becomes 1 and then 2 by n. We write n by n, it becomes 1 and then 1 by n. So everywhere this is the form we have. Students, before this, on page 21, limit at infinity is explained. If you see, then what is written there? Limit at infinity it is written. And just before part B, limit x approaches infinity, 1 by x is equal to 0. When x approaches infinity, 1 by x approaches 0. When x approaches infinity, 1 by x approaches 0. Here n approaches infinity, remember, 1 by n will approach 0. N approaches infinity, 1 by n approaches 0. So we write it here. As n approaches infinity, here we have 1 by n, 2 by n, it can be 3 by n later on, and so on. All these values approach 0. N approaches infinity. What does it mean, n approaches infinity? Infinity is very large value. N approaches very large value. When n approaches very large value and n is in denominator, numerator is 1, 2, 3, these are very small values, and we say that n approaches infinity means n is very large value. 1 divided by very large, 2 divided by very large, 3 divided by very large, every time answer will be approximately 0. When all these terms become 0, 1 by n, 2 by n, later on 3 by n, later on 4 by n, 5 by n, and so on, what this form becomes? It becomes 1 plus 1 plus 1 by 2 factorial can be written as 2 now. This is 1 minus, it is 0, plus 1 by 3 factorial is 1 by 6. 1 minus 1 by n is 0 because of applying limit. One minus 2 by n is 0, so on. This happens, students, here, and we applied limit, so left hand side we will have 1 plus 1 by n power n. It was the structure on left hand side, but now with the limit applied, n approaches infinity. N approaches infinity written on left and on right also. Right side, on right side it makes these changes. 1 by n, 2 by n, 3 by n, all these terms are now becoming 0. So this is 1 plus 1 plus, it is 1 by 2 into 1, 1 by 2, 1 by 2 means 0.5. 1 by 6, this will be 1 by 6, the product of these two ones will be 1 and product with 1 by 6 will be, it will be 0.1666, so on, this value. When all these terms are added, then the value becomes approximately equal to 2.718281. Hence I make conclusion, and this is denoted by E. This is called E, 2.718281. This value is called E. Hence I write this final result. I can write limit n approaches infinity, 1 plus 1 by n raised to power n. Value of this function approaches E. When limit approaches n approaches infinity, value of this function approaches E. The result and then the deduction. This was the result. Limit x n approaches infinity. 1 plus 1 by n raised to power n, answer is E. It's deduction now. A result deduced from it is limit x approaches 0, 1 plus x raised to power 1 by x is E. Now students, if you can see that these two are reciprocals of each other. N is power, 1 by n is in place of x. Now what is here? They are interchanged. Power was n. Now power is 1 by n form. It was written 1 by n here. Corresponding to that it is n. So if we can write it in the form of n approaches infinity, 1 plus n raised to power 1 by n. These two values are interchanged and the still result is e when limit x approaches 0. Previously n approaches infinity it was. When it is 1 by n here, n must approach infinity. If it is x here, it must approach 0. Then the result will be same. We can prove it. Its proof is, let's look at its proof. As we have 1 minus x raised to power 1 by x, limit x approaches 0. This the form we substitute in it. We want to match it with the previous result. So in place of x we must have, you know that we want to match it with this. So in place of x we should have 1 by n here. So we substitute x equal to 1 by n. Or it can be written, look at the power here, it is n. This power must be equal to this, as we want to match this form with original. So power is 1 by x, we want it to be n here. Now because of this, what will happen? As x approaches 0, we write here, as x approaches 0, if x approaches 0, 1 by x approaches infinity. X approaches 0, x is in denominator value becoming smaller and smaller. X approaches infinity means x in denominator and approaching and getting smaller and smaller. The answer will be very large. Answer is what? 1 by x. X approaches 0, 1 by x will be infinity, very large. This we've studied in on previous pages, we have seen it. On page 21 it is written, limit at infinity. What is written there? Limit at infinity is written on page 21 and its B part. Just before B part it is written, x approaches infinity, 1 by x approaches 0. It can also be written, x approaches 0, 1 by x approaches infinity. So x approaches 0, 1 by x approaches infinity. What? 1 by x is 1 by x is an n approaches infinity, it means. So the new limit will be there. Therefore, what can we write? Limit x approaches 0. 1 plus x raised to power 1 by x is equal to. In place of x approaching 0, we have to write n approaches infinity. Now 1 plus, in place of x we are writing 1 by n. In place of 1 by x we are writing n. So this is the previous result which we proved and its answer is e. So answer of this result is also e. This has been proved. Next is another question from page number 23. Another proof. It is written, limit x approaches 0, a power x minus 1 divided by x. The answer is log to the base e of a. It can also be written as log to the base e is denoted by ln of a. So this can be proved easily. What is the proof? Let's look at it. So students, we want to make this form easier, and for this we substitute this numerator form. Put numerator ax minus 1 is equal to y. From here can we find value of x? For this we take this 1 on the other side, it will be 1 plus y. Then if we want to find x, how is it? This is exponential form. We can write it in the form log to the base a of 1 plus y is equal to x. Look at it. This a is the base. A is the base of the log. and log will apply on 1 plus y is equal to the power of x. Students, you know this already. 10 power 1 is equal to 10. It can be written as log to the base 10 of 10 is equal to 1. This is the base appearing here. This is on which log is applied, and equal to power is 1. These two are with if and only if sign with one another. 10 power 2 is equal to 10 100. We can write log to the base 10 of 100 is 2. 10 is the base, log applies on 100, and answer is 2. This is how we convert these log forms. This is the base appears with the log, and log applies on 1 plus y, the other side value, and equal to power is x here, power is 2 here. So these are the ways to convert log into exponential form, exponential into log. We converted exponential form into log form here. So after this, as we say, we are going to substitute in it. Now we have had to evaluate this limit. Limit x approaches 0. Ax minus 1 by x. What it will be written as? One thing more we will see, that if x approaches 0, then it becomes a power 0. A power 0 is 1. 1 minus 1 0. Then y becomes 0. So we can write this fact here, that as x approaches 0, y approaches 0. X approaches 0, it becomes a power 0. A power 0 is 1. 1 minus 1 will be 0. Y becomes 0. As x becoming 0, y also becomes 0. So in place of x approaches 0, we write y approaches 0. Ax minus 1 as a replacement y, divided by x as a replacement log to the base a of 1 plus y. Students, this can be written as y approaches 0. This can be written as 1 by log to the base a of 1 plus y divided by y. From first place to third, y has been shifted, and then we have limit y approaches 0. It can be written as 1 by y log to the base of a 1 plus y. So as y is at third place, still it is at third place. Previously it is written in the denominator the whole value. Now it is written as 1 by y, the same form. Now this is the coefficient. Coefficient can be converted into power. Power can be converted into coefficient due to action of log. So limit y approaches 0, 1 by, this can be written log to the base a of 1 plus y power 1 by y. Limit can be applied in denominator only, and limit can go with the function without taking care of the application of the log here. Can move inside log, can appear with the function. So limit y approaches 0, 1 plus y, 1 by y. So we know this log to the base a of. We know this fact that 1 plus x raised to power 1 by x approaches 0. Answer is E. If this is inverted, it is 1 by log to the base a of E. If it is inverted, it becomes log to the base e of a. Now it is written the denominator log to the base a of e. They will get interchanged. A and e. A is the base e on which e is the value on which log applies. E becomes base and a will become the value on which log applies, and this is natural log of a. This is answer, students, answer of our limit. We had to prove and we did. इसमें ऐसे है कि इस लिमिट का आंसर हमने फाइंड आउट करना है log टू द बेस e ऑफ a यानी नेचुरल log ऑफ a, क्योंकि log टू द बेस e को नेचुरल log से डिनोट कर सकते हैं। अब इस लिमिट को इवेल्युएट करते हैं कैसे, हम इस न्यूमरेटर स्ट्रक्चर को आसान बनाते हैं, इसकी जगह y लिख देते हैं, आसान सी फॉर्म ax माइनस 1 कॉम्प्लिकेटेड है तो मैं ax माइनस 1 की बजाय क्या लिख देता हूँ y। इससे ये फिर जाहिर है पूरी स्ट्रक्चर कन्वर्ट होगा इनटू न्यू फॉर्म। फिर क्या होगा देखें, इस x के एक्सप्रेशन को मैंने y लिख दिया, यहाँ से 1 को उधर भेजें तो ये a पावर x की वैल्यू y की फॉर्म में बन जाएगी, a पावर x इक्वल टू 1 प्लस y। अब ये जो x पावर में है ना उसको पावर से हटाने का क्या तरीका है, लॉग की एप्लीकेशन। तो ये देखें कैसे इसको कन्वर्ट करेंगे लॉग की फॉर्म में। a बेस है, यहाँ e पावर x a पावर x लिखा हुआ है, a पावर x मीन्स a इज द बेस, x इज द पावर, a इज द बेस। तो हम इसको लॉग लिखेंगे, लॉग में भी a को बेस लिखेंगे, log टू द बेस ऑफ log टू द बेस a of the value written on the other side 1 plus y equal to the power is x। तो इस तरह लिखेंगे log to the base। ये देखें ये बेस है एक्सपोनेंशियल की, log की भी बेस होगी और log अप्लाई होगा इस वैल्यू पे और इक्वल आंसर क्या आ जाएगा, आंसर आ जाएगा पावर x। log to the base a of 1 plus y is equal to x। अब ये गिवन फॉर्म है, ये गिवन फॉर्म मैंने लिखी है। अब एक और बात देखें, यहाँ पे अगर x अप्रोचेस 0 है, x की वैल्यू 0 लिखेंगे तो a पावर 0 बनेगा, a पावर 0 1 हो जाएगा, 1 माइनस 1 0 हो जाएगा तो y भी 0 हो जाएगा, x के 0 होने से y भी 0 हो जाएगा। सो मैंने ये लिख दिया एज x अप्रोचेस 0 y आल्सो अप्रोचिंग 0। जाहिर है यहाँ एग्जैक्ट 0 की तो बात नहीं है, x अप्रोचेस 0 है तो y भी 0 को अप्रोच करेगा एज x अप्रोचेस 0। तो अब आप देखें ये गिवन था लिमिट x अप्रोचेस 0, मैंने उसकी जगह लिख दिया लिमिट y अप्रोचेस 0। ax माइनस 1 की वैल्यू मैंने लिखी है y, ax माइनस 1 इज y। देन वहां से मुझे x की वैल्यू log की फॉर्म में मिली थी log टू द बेस a ऑफ 1 प्लस y, तो इस x की जगह लिख दिया log टू द बेस a ऑफ 1 प्लस y। अब ये फर्स्ट प्लेस पे जो y है इसको यहाँ से हटा के थर्ड पे ले आए तो वहाँ 1 रह जाएगा, ये थर्ड से फर्स्ट पे जा सकता है, फर्स्ट से थर्ड पे आ सकता है, ठीक है। ये तो हम फॉर्म बना रहे हैं। अब देखें ये y थर्ड में कि थर्ड प्लेस पे है, डिनोमिनेटर ऑफ दिस डिनोमिनेटर वैल्यू, इट इज डिनोमिनेटर ऑफ दिस डिनोमिनेटर वैल्यू, तो 1 डिवाइडेड बाय फ्रैक्शन है जिसमें y थर्ड प्लेस पे है तो y स्टिल थर्ड प्लेस पे। अगर इसको 1 बाय y लिख देंगे इन द डिनोमिनेटर, तो अगर 1 बाय y लिख देंगे तो फिर भी ये थर्ड प्लेस पे है, बाकी log टू द बेस a ऑफ 1 प्लस y लिखा है। उसके बाद आप देखें लिमिट उसी तरह लिमिट y अप्रोचेस 0 साथ आती जाएगी। फिर आप देखें यहाँ पे ये कोफिशिएंट है, कोफिशिएंट को पावर बना देगा कौन, log, और पावर को कोफिशिएंट बना देता है कौन, log। इट कैन गो बोथ वेज। अब ये कोफिशिएंट है, पावर बना दिया, पावर होता तो फिर उसको कोफिशिएंट बना देते। ये देखें ना ये एक प्रॉपर्टी है log की, क्या प्रॉपर्टी है, log m पावर n इज इक्वल टू n log m। तो एक फॉर्म को दूसरी में कन्वर्ट कर दें, जिसमें भी आप कन्वर्ट करना चाहते हैं, पावर को हटाना चाहते हैं, कोफिशिएंट बनाना चाहते हैं, वो भी अलाउड है। यानी लेफ्ट साइड मौजूद है आपके पास, आप ये लिखते हैं उसके मुकाबले में, या ये मौजूद है उसके मुकाबले में ये लिखते हैं, तो बोथ आर अलाउड, ठीक है। तो हमारे पास कोफिशिएंट क्या बना था, इसको मैंने पावर बना दिया, यानी कोफिशिएंट मौजूद है तो कोफिशिएंट को पावर बना दिया। राइट हैंड साइड वाली फॉर्म मेरे पास थी, मैंने लेफ्ट हैंड साइड वाली फॉर्म बना दी, तो 1 प्लस y बिकम्स पावर ड्यू टू दिस प्रॉपर्टी। एंड नाउ हमें पता है कि ये लिमिट फंक्शन के साथ लिखी है, हम इसको दो फंक्शन डिवाइड हो रहे हैं, डिनोमिनेटर में लिख सकते हैं, डिनोमिनेटर में फिर फर्दर आप log के इनसाइड भी भेज सकते हैं लिमिट को। तो लिमिट log के इनसाइड चली गई, किसके साथ, फंक्शन के साथ। फंक्शन इज 1 प्लस y पावर 1 बाय y। अब ये जो वैल्यू फॉर्म है ना, ये अभी डिडक्शन हमने पढ़ी थी, डिडक्शन इस क्वेश्चन से पहले एक डिडक्शन पढ़ी है, डिडक्शन x की फॉर्म में पढ़ी है, ये एग्जैक्टली वही स्ट्रक्चर है। वहां लिखा था x अप्रोचेस 0, x अप्रोचेस 0 1 प्लस x पावर 1 बाय x, और इसका आंसर हमने e प्रूव किया था। सो इट्स आंसर इज आल्सो e, वेरिएबल जो भी हो इस स्ट्रक्चर का इस लिमिट पे आंसर आएगा e। तो यहाँ वेरिएबल y है, डिडक्शन में हमने x वेरिएबल पढ़ा था, सेम स्ट्रक्चर सेम लिमिट, सो आंसर विल बी e। अब ये डिनोमिनेटर में क्या लिखा है, log टू द बेस a ऑफ e, a बेस है, e पे log अप्लाई हो रहा है, इन्वर्ट करेंगे 1 बाय log है तो log बाय 1 लिखेंगे तो क्या हो जाएगा, a बेस e बेस बन जाएगा और a पे log अप्लाई हो जाएगा, यानी ये इंटरचेंज हो जाएंगे। तो log टू द बेस e ऑफ a बनेगा और log टू द बेस e को नेचुरल log से डिनोट करते हैं, तो ये आंसर आ गया। इसके बाद देखें इसकी भी डिडक्शन एक लिखी हुई है, और इसकी क्या डिडक्शन है वो भी देखते हैं।